variation problems. Okay, this should be a pretty quick section. And these really have nothing to do with our previous sections in chapter 3. We're not doing any polynomial graphing in this section. We are analyzing problems where more than one thing is varying together, right? Two things are varying at once. So we have different types of variation. So the types are going to be direct variation, inverse variation, and some combination of those, which we call joint variation. All right, so basically what's going on here is we're going to have something like this, where x and y are the two things that are varying according, that are varying with each other. And k is what we call a constant of proportionality. And the constant of proportionality is always going to be a number greater than 0. Okay? So when we look at it this way, notice here, if this number is always positive, then if this number grows, this number is going to grow also. Right? So this is what we call direct variation. As one variable grows, the other variable grows. If this one gets larger, then this one gets larger. Because k is a constant. Right? K is going to be some number. It's always going to be a positive number. So direct variation is when we're going to have this form. Okay. Inverse variation is we're going to have this form. So notice here, if this value grows, and this is always a number greater than 0, if this value grows, this number is going to decrease. That's why we call it inverse variation. As one grows, the other decreases. Up here, as one grows, the other grows. Direct variation, they're going in the same direction. Here they're going in the opposite direction. As one gets larger, the other gets smaller. And joint variation is just some combination. There's always going to be a k, but there could be an x, there could be a w, there could be a v, other variables involved, and some might be direct, and some might be inverse, right? Some sort of combination of inverse and direct, and maybe more than two variables. And that's all that's going on here. So these questions are pretty straightforward. You're going to be given, first you have to decide which of the cases we're looking at to come up with the correct equation. That's really the key. Then you're going to be given some information that's going to allow you to solve for this variable. And then you're going to be given all except one of the remaining variables, and you'll be asked to solve for that one remaining variable. So let's look at a few of these of each different type. Okay, so I'm going to look at checkpoint 1 here. Checkpoint 1 on page 425. All right, so it says the number of gallons of water. So first label your variables. Right? It's not always going to be x's and y's, whatever variables we're using. So W is gallons of water. And T is the minutes for a shower. How long it takes for somebody to take a shower. And we are told in this question, it says the water used when taking a shower varies directly as time. Okay, so we are told that W varies directly, that's the key, as time. So that information allows us to form this equation. And that's really the key, forming the correct equation. Water, K, always put K in the numerator. Okay? K is always going to be a positive number Always put it in the numerator no matter which kind of variation we're looking at. We're told it varies directly as t, so t is also in the numerator. And now we have what we need. Now we're given some information, and it says a shower lasting 5 minutes uses 30 gallons. Okay, so this is the equation we want. Equation of variation. Okay, we're given that the water used is 30 gallons when t is 5. Okay, using this information now allows us to find k. We say, we put the w and the t into the formula, and we solve for k, and we get k is 6. Okay, now we can put that k back into the formula and answer any other question. Given any t, what is w? Given any w, what is t? And that's generally going to be a follow-up question. It says, how much water is used in a shower lasting 11 minutes? So now using this to answer the question, what is w when t equals 11? So we're just plugging 11 in there, and we get 6 times 11 or 66 gallons. And that's our answer. So 2 parts, 3 parts actually, 3 parts. You got to come up with the correct equation, then you're going to use the given information to find the constant, and then you're going to be asked a follow-up question. So the key is to come up with the correct type of variation, then find k, and then answer a follow-up. So let's do a couple more. How about we will look at checkpoint 3. Let's leave that there for now. Checkpoint 3 on page 428. Okay, the length of a violin string. So we'll call that V, length of string. And it says varies inversely as the frequency of its vibration. So we'll let F be frequency. So label things, always good to make things clear. All right, and it says the violin string varies inversely as the frequency. So our equation, violin, varies inversely. K is always in the numerator, inversely, so frequency is in the denominator. Okay, so that's the key, coming up with the correct equation. And then we're given some information. It says the violin string, if V is 8 inches, we're told, we're given that when V is 8 inches, frequency is 640. So we use that information to find K. So we get 8 equals K over 640. So 4,832, what is that, 51, what the hell is that? 4,832, right, 320, 4,800 and 320, is that right? Did I get the answer here? 512, I was close. 512, wait a minute, what did I do wrong? Something's wrong there, right? Oh, no, I think I was right? What was K? Everybody got a calculator? Got a calculator? No. Okay, get your phone there. 600 times 8 would be 4,800. And then another 320. That should be right, right?
Yep.
Okay, so that's our K. Now we can plug that into the formula and answer the next question. So now we're going to plug that in and say V equals 5120 over F. And the follow-up question is, what is the frequency of a 10-inch string? So basically we're saying, what is F? What is F when V is 10? So we put 10 in, and we solve for F. If we multiply both sides by F, we get this. And nicely dividing by 10, we get 512 vibrations. Doesn't say per second. 512 per second. All right, so once again, come up with the correct equation. Use the given information to solve for K. Put that K into the equation. Answer the follow-up question. All right, let's do one where we have some joint variation, which is looking like checkpoint 4. All right, so joint variation means we got more than two things going on. So here, this is checkpoint 4, page 429. And it says the number of minutes needed to solve an exercise set of variation problems varies directly as the number of problems. So we're going to let n be the number of problems. Now you can label these any letters you want. Try to label them so you can keep things clear. And inversely is the number of people, so we'll let small n be the number of people. And directly is the number of problems, inversely is the number of people. Okay, so this is just two, no, there's two things going on, right? And blah, 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 blah. Number of minutes needed to solve, number of minutes needed to solve, that's the number of minutes needed to solve. All right, so number of minutes needs to solve this many problems if this many people are working together on them. And it says the number of minutes needed to solve, so number of minutes, it says varies directly. So K, remember, K is always in the numerator. So put K in the numerator to begin with. Varies directly as the number of problems, so that goes in the numerator. And inversely as the number of people, so that goes in the denominator. So that's the equation. Okay, so notice we got one more variable than we had in the first two examples. The number of minutes varies directly as the number of problems, inversely as the number of people. K always in the numerator. Now we're given 3 of those 4 variables in order to solve for K. So now we're given that it takes 4 people, 32 minutes to solve 16 problems. And that's going to allow us to solve for K, right? So we use this information here, and we say the number of minutes is 32, when the number of problems is 16, and the number of people is 4. And that's going to let us solve for K. If we multiply both sides by 4, we'll get 198. Wait, 4 times 120, right? 30 times 4 is 120, and another 8, okay? 16K. So what do we get there? 8? 8 times 16, 80 and 48, yeah. All right, so K is 8. That now lets us put the equation in, put the K into the equation, and then solve the next question. Next question says, how many minutes will it take 8 people to solve 24 problems? All right, so if n equals 8, and n equals 24, what is m? That's the question being asked. I believe we should make sure I got that right. How many minutes? Well, it'll take 8 people to solve 24 problems. Okay, so we're solving for m. We got 8. Number of problems was 24, and number of people was 8. So nicely, that gives us 24 minutes. All right, so that is an example of joint variation. All right, let's do one more just to make this absolutely clear. We'll do checkpoint 5. Which is another example of joint variation. Okay. Actually, let's do this one about the tallest man in the world. That was pretty cool. Let's look at number 25 on page 431. So this is about the guy, there's a picture of him here. Can you get that picture? Tallest man in the world. He was 8 feet 11 inches. Okay, so it says, if all men had identical body types, their weight would vary directly as the cube of their height. So their weight is going to vary directly as the cube of their height. So we're going to let W equal weight and H equal height. Okay, so cube of their, just be careful between cube and cube root, or square and square root. This is the cube of the height. And the picture of the guy, he reached a height of 8 feet 11 inches, or 107 inches at age 22. If a man is 5 feet 10 inches tall, so if the height is 70 inches, that's 5 feet 10, with the same body type as Mr. Wadlow, weighs 170 pounds. Okay, so that's going to allow us to solve for K, right? So a guy weighing 170 pounds is 70 inches tall. That allows us to solve for K. Now this is not joint variation, this is just direct variation. That's just an interesting problem, so that's why we're looking at it. All right, so this one says 170 K times 70 cubed. All right, you got your calculator there? What's K going to be? K is going to be 170 over 70 cubed.
.000495.
Okay, so we're going to say 0.000495 times h cubed. So that is the direct variation equation. And we can now use that. And the question now is, what was Robert Wadlow's weight, the tallest guy in the world, what was his weight before his death, if at his death he was 107 inches tall? So basically we're saying, what is W if the height was 107 inches? All right, well, we got two unknowns. We're given one of them. So all we got to do is plug that in. Weight is going to be times 107 cubed. And if we did that right, I got the answer here. It's about 607 pounds. And he wasn't fat, right? I mean, he looked like a pretty skinny guy, but he was 8 feet 11. So, weight would vary directly as the cube of the height. I think we did that right. Weight, cube of the height. A weird K, but that should be right. All right, that is variation.